This is a question under the topic of applications of differentiation. The question involves connected rate of changes. Okay, so essentially, you're given the rate of change of the radius, right? And then you're supposed to find the rate of change of the area. Okay, so rate of change is okay when you differentiate something, you're finding the rate of change, right? So you are finding the rate of change with respect. You're finding the rate of change of the radius with respect to time. So the symbol is dr dt, right? How much the radius changes for 1 unit of change in time. Okay, your dr dt is 1 over 5, right? You want to find the rate of change of area with respect to time, so that's dA dt. Okay, so to find the dA dt, right, you need to use your dr dt and multiply it by something else in order to get dA dt. Okay, so the trick is to find what this other differential is that you need to multiply, right? So you know that dr, after you multiply it will be replaced by dA, right? So in the denominator you want a dr there so that when you simplify it cancels out. Okay, that's the trick, right? So what is going to replace dr now that it's been cancelled out? dA. Okay, you need dA there. So that's how you find the differential that you need to multiply. Okay, so right, dr dt we know is 1 over 5, right? So we need to find the value of dA dr. So how do we even find dA dr? You just think about, like, normally, right, we have y equals to x squared plus 3x, for example, and then when we differentiate this, we take dy dx and that will be equal to 2x plus 3. Okay, so same idea here, right? You need an equation linking a and r, right? So a equals to something something r, and then after that when you differentiate with respect to r, that's how you get dA dr. Okay, so how is area related to radius, right? Talking about area of a circle is just pi r squared. Okay, so if you do dA dr, then it will just be 2 pi r. Because pi is a constant, right? You can treat it like a number, right? So you just bring the 2 down, you multiply it, and then the power of 2 reduces by 1, right? It's 2 minus 1, which is just 1. So that's how you get 2 pi r. Okay? So now that you have your dA dr, you can just substitute that into the formula, right? So dA dt equals to 1 over 5 times 2 pi r. So the answer is just 2/5 pi r cm per second. Sorry, it should be cm squared per second, right? Because we're talking about area. Okay, and this is not the end of it, because this is the general rate of change of area, right? But they're asking for the rate of change of area when the radius is 10 cm. Okay, so that's a specific point in time. That means the rate of change of area is not constant. So you need to sub r equals to 10 in here. So yeah, let this be equation 1, sub r equals to 10 into 1. So dA dt equals to 2 over 5 times pi times 10, which is 4 pi cm squared per second. This is the answer.